Myself Kalpana in the Department of Artificial Intelligence and Data Science, working at Shriram Engineering College. Welcome to this presentation on neural network fundamentals. In this session, we will discuss the perceptron, forward propagation and backward propagation. We will explore how data flows through a neural network and how predictions are made and how the network learns from its mistakes. Let's begin with the perceptron, the simplest building block of a neural network. A perceptron takes inputs, multiplies them by weights, adds a bias, and passes the result through an activation function. If the output crosses a threshold, the neuron fires. This model is powerful for basic binary classification, but it cannot handle complex problems without hidden layers. Next, forward propagation. Forward propagation is the process of making predictions. Input data flows from the input layer through hidden layers and finally to the output layer. Each neuron calculates a weighted sum of its input and applies an activation function. The final output is the network's prediction. For example, predicting the price of a house based on its size, number of bedrooms, and locations. Next, error calculation. Once the prediction is made, we calculate the error. Error is simply the difference between the predicted output and the actual target value. For example, if the predicted house price is 26 lakh, but the actual price is 28.5 lakh, the error is 2.5 lakh. This errors tell us how far of the network's predictions was. Backward propagation. Backward propagation is the learning phase. The error is sent backward through the network. Using the chain rule of calculus, gradients are calculated for each weight. Then weights are updated using gradient descent algorithm. This process reduces the error step by step, allowing the network to improve its predictions over time. Next slide, activation functions. Activation functions play a critical role. They introduce non-linearity, allowing the network to learn complex patterns. Common activation functions include sigmoid, which squashes values between 0 and 1, then rectified linear unit, which outputs 0 for negative inputs and the input itself for positive values, and softmax, which is often used for classification tasks, which is also called as differentiable activation function. To summarize, the perceptron is the basic unit of a neural network. Forward propagation makes predictions, error calculation measures accuracy, backward propagation helps the network learn, and activation functions give the network flexibility to model complex relationships. Together, these concepts form the foundation of deep learning. So, this is one example. First step, calculate the error signal. We start by computing the error between the predicted output and the actual target. Suppose the error is 4.0. The error signal denoted delta. Delta is the derivative of the error with respect to the activation. In this example, delta equals negative 1.2. Next step, compute the gradient. We calculate the gradient, which tells us how much each weight contributed to the error. The formula is gradient equals delta multiplied by the activation function, with delta equal to negative 1.2 and activation equal to 0.8. The gradient becomes negative. So finally we got 0.96. Then step 3, update the weights. Finally, we update the weights using gradient descent algorithm. The formula is delta weight equals negative learning rate times the gradient. With learning rate of 0.1, delta weight equals to plus 0.96. If the old weight was 0.5, the new weight becomes 0.596 because predicted output minus actual output. Backward propagation allows the network to learn by adjusting weights step by step. In this example, the weight was updated from 0.5 to 0.596, reducing future error and improving predictions. That's all. Thank you.